Good afternoon, everyone, and welcome to the Institution of Mechanical Engineers webinar on rapid re-engineering of the CPAP. I'm your host, Dr. Helen Lees, and I'm Vice Chair of the Biomedical Engineering Division at the institution. And I am really excited today to be part of this presentation. It's going to be very packed, but please feel free to leave questions for the speakers, and I'll make sure that they get those questions during at the end of the presentation. So without further ado, I want to start by introducing the team that we have today. This is a team that's been brought together by Mercedes Formula One Manufacturing and the clinical team at the University College Hospital in London. They've come together and in such a short space of time have taken an existing CPAP device and have prototyped a new one in just 100 hours. They gained medical approval for the device in 10 days and in order to distribute 10,000 units to the NHS in 4 weeks. This is such a feat of engineering. I'm really excited to hear what they have to say. And I'm going to start by introducing Professor David Lomas. Professor David Lomas is the UCL Vice Provost for Health, and he is the head of UCL School of Life and Medical Sciences. He's the clinical lead for patient emergency response and resuscitation, and has also been involved in critical care for the hyperacute stroke unit. So, David, over to you. I'm very excited to hear what the team has got to say.
Helen, thank you very much, and thank you for inviting us to do this webinar. As you've just said, we will hear, I think today, a remarkable story of how a team came together and worked at pace and speed to do something remarkable in the face of the COVID-19 pandemic. I want to stress at the heart of everything we did was partnership with industry, and a partnership that was of many years in the making. A partnership between the UCL Institute of Healthcare Engineering, the UCL Division of Medicine, University College London Hospitals, and Mercedes AMG HPP, or High Performance Powertrain. That's the Mercedes F1 team. We'll also hear how the regulators worked at really unprecedented speed. Things that took months were done in hours and days in the face of the epidemic, and also how different companies stepped up to help manufacture the device and the components and distribute the kit to the NHS. I've asked each speaker to introduce themselves. They'll talk between 5 and 7.5 minutes, and then we'll hand back to Helen for a panel discussion. So we're going to kick off, first of all, with Professor Mervyn Singer and Dr. Dave Brearley. And Mervyn and Dave, you were there at the start. You were there in the house room at UCL when this was all discussed and planned. So over to you.
Thank you, David. So good morning all. I'm David Brearley. I'm an intensive care and anaesthetic consultant at the University College Hospital. And what I thought I'd do is I would start this by trying to answer the question, what is CPAP? Well, CPAP stands for continuous positive airway pressure, and it's a way of being able to give oxygen under pressure to a patient's lungs. And it's part of a range of modalities that we have to treat hypoxemia. And by that I mean low levels of oxygen in your bloodstream. Look at this steps. Perhaps the first step would be to give increasing amounts of oxygen through simple face masks. But as that's failed, you step up to giving CPAP. And should CPAP fail, you then step up further to something called invasive mechanical ventilation, where we put you off to sleep, or a tube down the back of your throat, and get a machine, a ventilator, to blow oxygen and air in and out of your lungs. And should that fail, then the very final step is ECMO, extracorporeal membrane oxygenation, where in fact we bypass the lungs altogether. We take the blood out, put it through a artificial membrane oxygenator before giving it back to you. Now, it doesn't take much in the way of imagination to think those last two steps are two very big steps. They require an awful lot of technical expertise and resource, and carry with them some really significant side effects. So if you can avoid them, you're best off doing that. And that's where CPAP comes in. Now, CPAP works by delivering pressure to the patient's airways a pressure of somewhere around 5 to 15 centimeters of water. And that pressure splints open the lungs, it recruits collapsed areas of lungs, and if you like, can push fluid that might have leaked out of your circulation into the alveoli, that's the business part of the lungs, they can push the fluid back in again. And that can really significantly improve your work of breathing and improve your oxygen levels. Now, some of you may have come across CPAP before all of this. It's frequently used to treat something called obstructive sleep apnea, where you snore too much at night time. And there we're using the pressure to, if you like, splint open your upper airway, where in COVID-19 and heart failure and other diseases, we use it to splint open the lower airway. So to deliver CPAP, we need a number of things. We need first an oxygen supply, slightly bigger one than this, but you get the idea. We then need a flow generator, a pressure generator. There are lots of them around. Personally, I prefer the UCL-Ventura. And that just plugs into your oxygen supply, and then we just need a circuit to be able to take that oxygen down to our patient, and then we apply that oxygen essentially through an interface, which is another word for a mask. Now this mask then straps tightly onto your face to allow you to deliver the oxygen under pressure. Now the problem here is, of course, if we get any leak in this face mask, we start to lose pressure and therefore the effectiveness. So this interface has to be very tightly applied. And despite having a very soft sort of sealant there, it can cause pressure problems on the nose. Patients find it pretty uncomfortable. It's difficult to talk, it's difficult to eat, it's difficult to drink through it. So we find that patients ultimately go through a range of different masks, in fact, even to full hoods that look like space helmets, before they find the one that works for them best. But eventually they do. So that's CPAP, and now what I'm going to do is hand you over to Professor Mervyn Singer, who's going to tell you a little bit about how CPAP was going to work. Okay, Mervyn.
Lovely. Thank you very much indeed, Dave, and good afternoon, everybody. So you've heard Dave describe CPAP as a sort of bridge between an oxygen mask alone and an invasive mechanical ventilator. However, when COVID-19 came along, there was a fear that the high flow generated by CPAP would aerosolize viruses and therefore present a healthcare risk to the doctors and nurses looking after these patients. And so advice from the World Health Organization and other national guidelines, including the UK, was to try and avoid these sorts of techniques. However, when the disease hit China and then Italy big time, it basically overwhelmed their hospital resources. In particular, they ran out of ventilators, critical care beds, and by necessity, they turned to using these high-flow devices like CPAP and another device called high-flow nasal oxygen. They found a few important features. Firstly, about half of the patients who would otherwise have been mechanically ventilated were spared from this. They could prevent the need for ventilation in half these patients, and as these patients took approximately 2 weeks to get better, it meant there was a much more efficient use of this very scarce resource for the patients who most desperately needed it. Secondly, and again, we were in contact with multiple colleagues around China and Italy. They didn't find any doctor or nurse looking after these patients suffering themselves from a serious COVID infection. And thirdly, these devices are more oxygen hungry, and so therefore there were concerns about hospital oxygen supply, and they all reported no major issues. So when we heard what was happening in China and in Italy at University College Hospital in London, we felt, against national guidance, that it was more appropriate to adopt this early CPAP strategy to try and protect our critical care beds and our relatively limited ventilator resource. Unfortunately, we only had 12 standalone CPAP devices in the whole of the hospital in the whole of the trust. So clearly we needed more, but as with everything, there was this sort of worldwide shortage of ventilators, CPAP machines, and so forth. Around the middle of March, Boris Johnson announced his ventilator challenge, and he was encouraging British industry to rise to the occasion and rapidly develop new ventilators at speed to cope with a modelled need for up to 40,000 intubated ventilated patients. However, in the whole of the UK, we only had 8,000 ventilators, and so there was this big shortfall. To my simple view, this was completely unrealistic because to develop a ventilator from scratch is quite a feat in itself. These are very sophisticated machines, and a very basic, simple ventilator wouldn't be able to cope with the complexities of ventilating a severely ill COVID patient. As part of this ventilator challenge, Becky Shipley, who will be talking after me, she was approached by DFID to try and help a consortium get together for this ventilator challenge. And we met with her and Tim Baker and expressed the view that what we didn't want are ventilators. What we did want is something to keep people off the ventilator, namely a CPAP device. And I'll now hand over to Becky and she can continue the story. Thank you for listening.
So, Mervyn and Dave, thanks very much. And Dave, thanks for the terrific props illustrating how the bits go together. Thanks very much. So Tim and Becky, this was all an engineering problem and required an engineering solution and reverse engineering an old device. Tell us what happened.
Okay, I'll let Becky start because she was the first point of contact.
Brilliant. Hi everyone. It's a pleasure to have the opportunity to tell you about this story today. So just to introduce myself, I'm Becky Shipley. I'm a professor of healthcare engineering at UCL, and I also run our Institute of Healthcare Engineering, which is all about interfacing engineers with our colleagues in medical sciences and through our UCL partner hospitals as well. Now, as Mervyn very nicely set up, we kind of really got our call to arms to work with our clinical colleagues and help them basically build capacity of CPAPs or these non-invasive ventilation devices for the NHS. Now, you're going to hear a lot about the rest of this story through the subsequent speakers. So I think for me, I'll just highlight a few of the key themes that, as someone at the healthcare engineering interface, this was really set up and necessary to make the project a success. So I think the first key theme was really that we needed a team that encompassed our mechanical engineering expertise, the healthcare expertise through the hospitals, and manufacturing capability. And that's really what we came to very quickly when we first met with Mervyn on the Tuesday evening. I think it was the 17th of March. Now, that composition of that team was really essential and meant that we could really tick the boxes of all of the components that were necessary to enable us to move very quickly at pace. Tim's going to fill you in on the core kind of mechanical engineering challenges, and Andy will talk about the manufacturing side of things, as well as some of our other industry partners on the call. Now, the other really core component to this was not only the collaboration with the clinicians, but the continuous capability to ask them questions, to understand from their perspective what the needs were for these technologies, and to be able to test continuously in the hospitals. And that's quite a rare situation to be in, I think. But it meant that we could move from getting a prototype that was working to being back in the hospitals testing it and understanding from Dave and Mervyn's experience what you needed and how these things were used. And I think that capability was absolutely pivotal. Next was really the regulatory stance. So we knew from the beginning that whatever we did, we were going to have to obviously get it approved by our medical regulator in the UK, who are our UK body that assess whether a device is safe and effective for use in patients. That necessity for speed really focused us on reverse engineering an off-patent device. But our collaboration with the regulator and Neil in particular was, again, absolutely pivotal. And that was, again, a collaboration which was set up and meant that we were in daily, if not more regular than that, communication throughout the development phase, and meant that we got our first approval within 10 days of our first meeting. The other two components that I just really want to flag before we move on are that one of the massive strengths, I think, of engineers is to take a systems level approach. So in this instance, it was never going to be sufficient just to focus on the CPAP device, because you can't use a CPAP device unless you've got the breathing circuits that connect it to a patient, or the oxygen analyzers, or indeed have thought about supply chains, etc. So I think, just speaking to an engineering community, I think that really exemplifies the role and kind of thinking that engineers can contribute to these kind of problems. And then I think my final comment was really that we started by learning from our international colleagues in China and Italy, based on Mervyn and Dave's networks, to focus and define our strategy around CPAPs. But then ultimately we all felt very passionately that our duty was really to make these available through a humanitarian approach to colleagues internationally. So ultimately we made all of these designs and manufacturing instructions available at zero cost, and that was something that was, I think, absolutely the right thing to do, and has been taken up very widely. So there's been over 1,800 downloads of the designs across the world, and that's something that we continue to invest a huge amount of effort in doing. So with that, I'll pass on to Tim, who I think is going to talk more about the mechanical engineering response.
Thanks, Becky. So hi to everyone. I'm Tim Baker. I'm a professor of mechanical engineering design at UCL. And just to give you a bit of the background, so I think like everyone else, I saw Boris's call to arms to start making mechanical ventilators on Sunday, the 15th of March. And kind of figured that maybe that was quite an ambitious plan to be producing ventilators from scratch in such a short space of time. So my background is in motorsport, and I guess like a lot of us, I kind of thought, well, if it was down to me, what I would do is go a slightly different way and perhaps look towards the strengths of the motorsport industry to help out. So I'd probably describe myself as being a bit of an accidental engineer all the way through my career, because I never expected to end up in academia, and I certainly didn't expect within 48 hours to be involved in the CPAP project. But I came into work as usual on the Monday, and then on Tuesday, having had a sort of one of those classic corridor conversations, I said to my family that I'll see you later on, as I left on the Tuesday, not realising that it'd be 4 weeks before I went back home. I met with the team to have the sort of get together, the social drink on the Tuesday evening to discuss what we could possibly do, and that's really where things started picking up with a pace. So I've got good contacts, obviously, within the motorsport industry, and the first thing I did was to contact the head of mechanical engineering at Mercedes HPP, Ben Hodgkinson. He's someone I've worked with throughout my career, and he works as a visiting professor at UCL. So we got talking about the possibilities of what we could do. With the guidance with Dave and Mervyn, we realised that we were going to be looking at reverse engineering an existing device. So that's what happened. By the Wednesday, we'd gathered a team. It was quite scary because London was emptying and it was becoming a bit of a sort of a ghost town. As we were sort of heading together to form this team. And what we did was we started by getting existing devices physically. Dave's going to enjoy this because I've actually got one of the devices that, I think this is the one, Dave, that you lent to us out of your prized collection. We didn't know that at the time, and the first thing we did was to put a bandsaw through it and start sectioning it so that we could start taking all of the measurements. To start the reverse engineering process, to create a 3D model, to create the 2D manufacturing drawings. Meantime, Andy Cowell had told us that we could call on the might of what they could do to help with the manufacturing. So very quickly, the team rapidly expanded beyond the boundaries of UCL. So my role in all of this really was I was expecting I would be sitting down doing the hands-on design, but I sort of became the engineering coordinator for all of this. If you look at my phone bill over this period, it was astronomical. I spent most of my time on the phone talking to people. We obviously reverse engineered with the help of Mercedes, started producing the first batch of 100 items. We were commissioned by the Cabinet Office to produce the first prototypes, and we went from the initial idea on that Tuesday evening to being back in the hospital in under 100 hours. And then from that, what followed was the regulatory approval with the MHRA. You'll hear that part of the story in a moment with Neil Maguire. So we went through approval within 10 days, and then within 4 weeks, we had produced 10,000 of these CPAP devices. Just to cut a long story short, we delivered it well within budget. In a lot of ways, the easy part was the CPAP device itself, because we expected, having produced the first one and done all the testing and knew it worked absolutely perfectly, that we would turn up in the hospital, do the testing, pat on the back, and then we'd start making lots of them. But it didn't turn out like that. What actually happened was we found that we had too much back pressure in the system. It was going to be uncomfortable for the patient, but more importantly, it was going to use a lot of oxygen. So we then went into a development program to reduce the use of oxygen, and over a period of days, we came up with a patient circuit that worked with our device. Also, in doing that, we realized that the headlines were about ventilators and breathing aids, but behind the scenes, there was none of the consumables, the medical consumables, the patient circuits, the masks, the filters, the pipes, to go with any of the ventilators or breathing aids. So everybody was out there fighting for the same components, and you'll hear from Mike Hinton from Intersurgical in a moment about his side of the story. We also found there were no oxygen monitors. So apart from producing the CPAP, we didn't reverse engineer. We created from scratch not one but two different oxygen monitors to go with the kit that we produced. And again, we produced 10,000 of those units. And since then, we've also developed a breathing hood. As Dave mentioned, the masks can get quite sore around the face, so we've just had a breathing hood that's gone through approval. On the whole, we've developed a complete system. Finally, the last bit I just want to say is that we also discovered that getting these items out into the NHS was a task in itself. And I figured that probably the best way to do that was to tap into the automotive just-in-time logistics. Through my network, we were very lucky to find G10. And Nick Thomas is going to explain about how they became part of the team. So we, within a couple of weeks, we started manufacturing devices in huge quantities, and also set up a logistics arm so that we could distribute them outside the NHS supply chain, but delivering to the doorstep of any hospital within the United Kingdom. So that's really all I wanted to say, and I'm happy to hand on. Thank you very much.
Tim, thanks very much. That's terrific. I'm just going to say a few words perhaps about some of the political aspects that we had to grapple with during this programme. So you've heard that the development of the UCL-Ventura device took 100 hours from the first thought to the prototype. It was quite astonishing. But we faced formidable hurdles. The use of CPAP was not sanctioned for use in the NHS for COVID-19 patients for the reasons that Mervyn described. The government's ventilator strategy was about ventilators and not CPAP devices. And the surge of COVID-19 patients was expected to hit London in the Easter weekend. That was less than a month after the first discussions. So there was a frantic race to gain MHRA approval for the device, to re-engineer the NHS pathway so that we could actually use the device, and perhaps most of all to get some money from the Cabinet Office so that they would commission the device and then it be adopted by the NHS. Colleagues will remember that 2 days after the first meeting in the Houseman room, Becky came to me, and actually I wrote then to the interim chair of the MHRA, June Rain, and said, can you help us? We need to get this through a regulatory process that should be months, and we have hours and days. And June said, yep, we'll do whatever we can. And it was terrific. And MHRA was superb, as we'll hear a bit more from Neil later on. The team contacted Andrew Menzies-Gow, who's in charge of respiratory medicine for the NHS, and along with the Faculty of Intensive Care Medicine, we changed the guidelines for the use of these devices in this pipeline of patients with COVID-19 lung disease. So we wrote our letter on the 20th of March. On the 24th of March, whether it was us or other pressure, the guidelines were changed so we could now use this device. You might remember that London was emptying and we were in lockdown. So UCLH, the hospital, gave honorary contracts to the Mercedes team to allow them to come into London to continue working and not to be locked down in their homes. And finally, as Mervyn said, we grappled perhaps most of all with our colleagues in the medical profession who didn't want us to do this because CPAP would weaponize, aerosolize the COVID virus, the underlying virus, and that would cause risk to healthcare professionals. And also the concern that the device was oxygen hungry. So we were very aware of that, and you'll hear from Andy how Mercedes re-engineered that device to improve its oxygen usage. But this was a challenging time, and all of us on the team, we were on a knife edge. We didn't know whether the government would commission it. We didn't know whether our hard work was worthwhile. Becky phoned me up and said, "You need to phone Andy Cowell and tell him it'll all be fine." I don't think I've told you that, Andy, before. So I did exactly as I was told. I phoned Andy Cowell and said it would all be fine, with my fingers firmly crossed that the supply chains would hold, that we would get the commission, that we'd get the devices, and we would be fine. And in fact, it all worked out fine. We got the commission for the first 100 devices, which meant that we could secure the supply chain, we could pay the contributors, and we had a way forward. There then followed a press release that some of you may remember, and Fergus Walsh led that on the Today programme and on the BBC News. And Mervyn, Tim, Dave, Becky all became stars overnight as they featured around the world advertising this device. We then joined a call with the Cabinet Office and then with the Department of Health and Social Care, and I'll never forget it. In the space of 20 minutes, they commissioned 10,000 devices for £20 million, £2,000 a device. We actually did it for less than that, but then we had to do a contract. So UCL doesn't make devices, neither does Mercedes, but we rapidly put together a contract. It was signed off by the minister, and production was underway. The other point I want to stress is the point that Becky made, is that the international response was quite extraordinary. We were contacted all over the world. So we made the designs open source. They could be downloaded by anyone, anywhere in the world, and manufactured, but only for humanitarian good. I put a clause in that contract which said anyone making a profit would have to pay the money back to us as a penalty. This was purely for humanitarian aid. And the response, as Becky said, has been quite remarkable, with I think 1,800 licenses now approved and 30 countries now manufacturing the device. That's all I wanted to say. And I would hand over to Andy Cowell, because obviously the Mercedes F1 team were critical to the whole programme. So Andy,
thank you, David. Good morning, everybody. Andy Cowell from Mercedes AMG High Performance Powertrains. We're responsible for the Formula One power unit and also the Formula E powertrain for Mercedes Racing. So the call came through. Tim got out his little black book. He got in touch with Ben Hodgkinson, who spent the first day down in London. And by that evening, we sent another 3 engineers down to help with the reverse engineering effort. Information was coming back up to Brixworth, where HPP is based as well. And we could see that the challenge was not just to re-engineer, but to get tooled up so that we could make thousands of these devices and make them to a good quality. This was all part of the Formula One Project Pit Lane program. So there were Formula One teams working on ventilators, and then HPP really focusing on the CPAP project. We wanted a device ourselves. Tim had put a bandsaw through David's device, so we reached for eBay and managed to find a Whisperflow device for just £50 in Nuneaton, which is the hometown of our operations director. So he Thursday morning brought this device into the factory, and through a process of CT scanning it to get some more precise dimensions inside, we learnt. But mainly we put it on a test rig. So one of our development engineers swiftly set up a test rig with oxygen flow. And we saw this as crucial, but for both the development journey, but also for learning how we were going to pass off these devices. In the service manual, there was a very clear pass fail criteria for the flow characteristics, and we wanted to get that test protocol set up early on to both check that this device that we'd bought would meet that protocol. So if we were using that as a master, we weren't being fooled, but also to get our test lane set up for production. We took the device apart carefully. So the guy that was going to set up the production line, he took the first one apart, and that started getting our build tooling together. And then using a scanning electron microscope and the EDX analysis in that, we learned about the material composition. And then simple hardness tests as well also taught us about the heat treatment grades of the materials used in the valves. Our development department then produced 12 sets of bits. One of those devices is what went down to London on our first trip for clinical testing. We built two, and both of those devices went across the flow bench so that we could check the eBay one against these first two devices, so that we got a device left in Brixworth whilst the first one was being used for clinical trials. And all the way through this first stage, what we were trying to do was make sure that we were showing to the regulatory authority and to UCL that we understood the Whisperflow device, and we believed that we could reproduce exactly the same device. There was also the call for reducing the oxygen consumption, and so a Mark II device was developed, which was done via inlet port improvements and also a flow flag, so that the clinicians could set the device up precisely so that the oxygen wasn't wasted. As Tim mentioned, developing the system, making sure that the filter, the PEEP valve, the pipes, the mask were all low flowing so that the pressure drop was as low as possible on the flow generator, such that it used the least amount of oxygen. And a lot of that development work was done on the test rig that we set up in those opening days here in Brixworth. But then, as David mentioned, the call to make 10,000 devices, I'd rather boldly said that within 1 week we would be able to make 1,000 a day, and we needed to honour that. The first day we were only at about 600, but by the last day we were at 1,200. So we're very proud to say that by the 15th of April, we had created 10,000 flow generators, but we were also confident that the quality of those devices was good, because every single one had been across the test bench at the end to make sure that the flow characteristics were spot on, and all our material traces and checks in the assembly process were robust as well. As I think everybody's saying, a lot of this was down to relationships and trust. We were keen to support right from the start. There was supposed to be a race on the 15th in Australia, but that was cancelled, which meant that this project was right at the top of our priority list, and we just worked hard to deliver to the project. There were no NDAs in place. There were no contracts. There was none of the normal commercial support. It really was just a case of let's just crack on. Let's put the best people on this project. There were hundreds of people that wanted to help, but we reached for the people that we thought were best placed to help, with time being the critical thing. And the relationship, I think, between UCL and Mercedes HPP was strong throughout, and I think is still strong now. Thank you, David.
Andy, thanks so much, and well done on the Austrian Grand Prix.
Thank you.
So of course, the whole thing hinged on regulatory approval. We had to get it past the regulators. Dr. Neil Maguire, you were critical. I still remember our first phone call. You were critical in terms of trying to look at this device and consider it for approval. Can you just take us through what happened? Neil, I think you might be on mute, Neil. No, I don't think we can hear you. there has been problems with Neil's sound and internet line during this presentation, so Neil may be struggling to get through. Neil, still can't hear you. Perhaps we can move on to Mike Hinton, if I may, and then Neil come back to you if we possibly can. So Mike, we've heard from Tim about the demands of the program requiring different tubings, filters, and devices, and that's where intersurgical came in. Do you want to just give us your perspective on the program and the call to arms, and what was asked of you in those weeks when the device was manufactured?
Yeah, quite a lot. So yeah, just to introduce myself, I'm Mike Hinton. I'm the operations director for Intersurgical globally. And yeah, I had the joy of being involved in the project from our end. To answer the question, an awful lot. You know, we produce the consumables that connect to the machine to the patient. So literally everybody across every single vent call, all the consortiums, as I'll talk about in a second, came along to us. And we were supplying everything from components for test machines through to systems that would eventually be used, but specifically for UCL, it was support in terms of components for the breathing system was going to be attached to the Ventura device. So just to give a bit of an idea about ourselves, or I guess where we were at the time when the crisis hit, normal growth for us as a business, or volume growth, is about 6 to 8%. So, you know, we're high volume manufacturers, and we have a lot of injection molding extrusion, but we're used to handling sort of what we consider to be 6 to 8% organic growth. From COVID Sunday, as we called it, or Tim, as you'd referred to it as, we saw an unprecedented growth in activity, primarily within the EU for critical care products, primarily, inclusive of the ones that ended up in the Ventura system, and also filtration in general, given the COVID sort of crisis in general. So in very short, for us, this put a huge amount of pressure on our supply chain and our production capability. When you couple this with what the UK COVID vent call was pulling down on, although we weren't directly involved with the Cabinet Office and we were aware that there were various streams happening, we had an awful lot of activity across those 20 some odd groups also. But the team at UCL, so Tim, Becky, Mervyn, Tom, they're amongst the first to contact us with requests for consumable parts, and we were excited to be involved and help support it. So we tried to do all our best at the start of this thing, and probably fondest memories for me were the initial weekend deliveries to drive your 24/7 development. So an awful lot of activity, air freights, and people delivering things to the group to keep the development rolling in that very short time frame. So the system itself, guys, you know, I presume most know, but if you don't, from our perspective, 10 core products from Intersurgical, or the CIRC, I'm going to say, depending on how you look at it. Tubing, filters, mask harnesses, connectors, PEEP valves, all things that we produce. These things are always viewed as the simple bit, and I think it's been alluded to, you know, they're an essential part of the treatment, and they can have a significant impact on therapy. So as Tim's mentioned, things like oxygen consumption in this respect, resistances, you know, there's an awful lot of work to be done there to configure and to fine-tune these things. In terms of logistics for us, they're produced in different factories, of course, so everything from the Far East to Europe, and the supply chains that drive those factories are also stretched globally. You know, huge issue for us, and also the final bit that we would have to be stocking these in the UK to support UCL and GTEM, who will speak next. So some challenges coupled with the global requirements from the basically everybody else in the world wanting the same things. So how do we achieve it? I think was the question you wanted to answer today, Tim. With some difficulty, I'd say, but primarily rationalization, supply chain logistics, and production engineering. So rationalization, so our business immediately turned off 95% of our products. When COVID hit, we make about 3,500 individual products, roughly, and that was reduced to 100, and that included those parts that we made for the UCL product. Supply chain, we had to reorganize our materials, components, and outsourcing to run alongside this. Our primary issue was the outsourced materials, metal parts like springs, some of the other subcomponents. The things you make yourself, as you probably know in manufacturing, are the easier bits. Those that come together to produce the parts are more complex. So lots of air freight. Logistics and management. So we had a dedicated business sales manager in the form of Carol, who needs a mention in the presentation. She did such an amazing job in supporting things. That was to ensure fluidity of supply to the UK against global demand. Director level involvement. So we committed from the top of this business to make sure that the supply came in, and that meant a green light for logistics, air freight, and supply. Interesting bits, production engineering. We had various elements like the PEEP valve, when before COVID were 40 units per hour fully tested, went to 240 fully tested. Extrusion, we turned all of our smoothbore extrusion lines onto making the tubing that was in the system. That's 6 lines, and extrusion rate output increases. Huge filter manufacturing increase, and then equally dedicating our injection molding to make those specific components to assist the system. So what does the future hold? Well, we've tried to support through the process. Approximately 15,000 systems have been supplied from Intersurgical to help support the Ventura project. We have many related developments in CPAP, which was seen as an old tech prior to this, oddly enough, and has come back around versus the fandangled ventilator, mask CPAP helmet technology. And then for us, really the ongoing involvement with UCL and the IMechE engineering group, optimization of circuits and interfaces. So that's my answer to the question, how did Intersurgical try to meet demand?
Mike, thank you. I do remember us all scrabbling for the same circuits, actually, in those heady days when we were competing with the Ventilator Challenge.
Yeah.
Neil, can I just check? Can you hear us now? Or can we hear you more to the point? I can see you, but I can't hear you, Neil. Still can't hear you. I'm going to ask Emma. Can you just try and liaise with Neil to try and see whether we get the audio, and we'll go on to Nick Thomas if I can. And so Nick, the challenge was, of course, to get these bits of kit, the CPAP circuits, out to the NHS in double quick time, in the just-in-time style of the F1 team. So you very kindly stepped up and helped out. So what was your perspective?
Yeah, good afternoon, everyone. Just to introduce ourselves. So myself, Nick Thomas, I'm director for GTEC Europe Manufacturing, so G10. So we're a first-tier manufacturing engineering company within the automotive sector. So traditionally, we manufacture automotive body structures for the likes of Toyota, BMW, and such. So entering into this project was a real sort of unknown for us. It was an arena that we were completely unaware of. Our involvement in the Ventura project started at the end of March. Our business was just going into stand down. All the major automotive OEMs within Europe were suspending production, and that was leading us into furloughing over 900 of our UK staff, which really was an unprecedented time for us. But as an automotive supplier, we also understood that we had key skill sets and importantly facility that had the potential to be repurposed and to support in any way we could against the fight against COVID. But we also understood that we as strong as we are within manufacturing, we weren't suddenly just going to start making ventilators. So that wasn't something that we dared to challenge, really. But what we could support in, we could use the arms of the business, such as supply chain management, logistics, and distribution, to try and offer a level of support to the CPAP and the Ventura project that was underway. So in our efforts to reach out, we were put in touch with UCL, who had indicated through some common contacts of ours that a level of support would have been welcomed particularly on the logistics and distribution side. So we had a very quick discussion with Tim and Becky down at UCL, and we immediately dispatched a couple of project managers down to UCL to really speak with these guys and understand more about the project and what we could do to help in any way. So our initial scope was based around receiving incoming stock items, so the items from Intersurgical, the items from from Mercedes, and in total about 10 different suppliers, and they ranged from the complex bits and pieces all the way down to simple packaging and the like, everything that's needed to actually package and distribute. So our initial scope was to receive incoming stock, take the orders through the NHS system, and to get the devices and deliver them into the NHS hospitals. So our activity started. We adopted the current ordering and procurement function from UCL. We were keen to do this. It had got to a point in the project where we could really see that the UCL staff, particularly Tim's area, really needed to give their time back to the continued development of the project, and not get bogged down in supply chain management and chasing around after stock items coming into the business. And as Mike indicated, there was a strong global demand for every item that we were trying to chase down. So we were contacting the manufacturing and supply base within the medical supply as an unknown customer, really, and some of the difficulties that we were finding, global back orders on all of the items that we were after. The whole ventilator challenge, where numerous companies were all chasing down the same consumable items, meant that stock had been disappearing rapidly into other businesses that were trying to develop a product, and to a certain level, stock was being taken and sitting there in warehouses not being consumed, which was particularly frustrating because we wanted to get our hands on it and get them into the hospitals. So we quickly formed a procurement function, our procurement team, purchasing project staff, and we were also able to draw on our global purchasing offices to locate and expedite stock, and search for availability. So we onboarded the procurement, and started the task of chasing in the stock. As Tim mentioned, the CPAP devices themselves, they were delivered every day. We were going into Northampton, and the stock was there, 1,000 units every day religiously. So that wasn't the issue. The issue was generally the consumable items, where there was a huge global demand for. So through numerous activities, we were able to secure the stock, I think. But we get a lot of questions of how we were able to get our hands on stock that everybody was finding it difficult to secure. And one of the big things for us was the items, particularly from intersurgical, that everybody was in demand for. What this project was able to do is able to demonstrate that the stock that we could get out of intersurgical on a Monday evening would be in an ICU unit on the Tuesday morning, and that made a big difference. Everyone within the supply chain, from intersurgical through to any of the other commodities that we were buying in sort of oxygen hoses, even packaging, there was a real desire to help and to service anyone that could actually get the product directly to the NHS hospitals. We were given priority, so that's generally one of the reasons why we were able to get our hands on stock that everybody was after, which is.
And it was a fabulous effort, Nick, and hugely grateful. Thank you. I do remember you joining the team and bailing us out because we had a room full of stock. We knew where to put it. I'm going to move on, if I may, because I want to try and see Neil Maguire. Neil, can we just see whether your audio is working?
Can you hear me now?
Neil, I can hear you. I can't see you, but I can hear you, and that's perfect. So, Neil, over to you. You were the linchpin. You were the critical bit of the regulator in the whole process.
That's very kind of you to give me that credit. So my background is intensive care medicine and anaesthesia. I've been in full-time medical regulations since 2014. I first heard about the UCL Mercedes CPAP endeavour on the 20th of March this year. The first chat I had with the team was on the 21st of March, the following day. and the first submission to me was the 25th of March, and there were a number of rounds of questions, and the first special authorization to legally supply was issued on the 27th of March. But what the team didn't know was, after our conversation, I'd already started to draft the letter to give them permission to legally supply. But of course, because regulators are inherently suspicious of people and their motivations, etc., there is a system in place which still can't be subverted just because there's a crisis. As we said at the beginning, there's it's better to have no CPAP at all than have bad CPAP, and we'd applied that mantra to the ventilators. The trick in all of this for me was that all my colleagues were dedicated to the ventilator challenge, and that left a very small team of me to sort out the CPAP and ask the questions. But we still managed, with the help of one of my colleagues in Birmingham, to produce the specification for CPAP, which we put online. So the rapidly manufactured CPAP specification, which was actually completed on the 23rd of March, and a final version was up on our web pages on the 29th of March. And we'd been using a modified essential requirements document, which we had to produce from scratch, because normally it takes up to about 2 years for a device to get onto the market and become commercially available, because of all the testing that's required. The team at UCL and Mercedes had a bit of a head start because they were reverse engineering something, and we were pretty rapidly able to gain confidence in what they were trying to do. The biggest bit of confidence was that this wasn't about ego and self-promotion. This was all about helping patients. And that's what we do as a regulator. And everybody's overriding principle was the patient comes first, and patient safety is the highest priority. It was a bit of a double-edged sword for the guys, because actually we wanted more reassurance, not less. And normally in the regulatory process, we oversee the system. We don't do the CE marking testing. We don't issue the CE certificates. What we do is we oversee the process to make sure it's all fair and above board. And in this case, because the notified bodies were so busy with so many other things, we actually had to take the place of the notified body in all of this. And it was clear to me that the team were working flat out, and I wasn't going to be outdone. So I worked flat out as well. And as Becky said, we were in daily, if not hourly, contact for all of the time that this was all coming together, to make sure that we still maintained the trust and the confidence in what was being done. And in those few days in between first hearing about it and the first letter going out, they had managed to produce the devices, test the devices, have healthy volunteer studies done, an independent assessment of the device, and also put together a small clinical investigation, which then confirmed that this was a good direction to be going in. And this was at a time when the rest of the world was saying, you can't use CPAP, as Mervyn pointed out, because everybody thought it was going to spread viruses like mad. It was going to use all the oxygen on the planet, and it was a complete non-starter. So we were isolated in as much as we had the idea and we had to put the plan in place in the face of some quite tough opposition within the clinical community. And it was the background work done by Mervyn and by David and other people, and Rebecca as well, that actually convinced the clinical community this was a viable thing to do, and it was going to help. It was going to keep people out of intensive care and take some of the stress out of the rest of the system. And just to make it worse for them, I was erring on the side of additional safety, because some of these devices are not normally used full time with oxygen monitors, and I knew that would be a problem for them, but the problem turned into a solution, and an elegant solution. The first monitor used medical grade components, so it wasn't so much of an issue, but the second was a leap of faith to use automotive components, which actually turned out to be better than the medical equivalents. So with those leaps of imagination and the trust we'd built up, I was able to give permission to supply 2 sorts of oxygen monitors. And then to top it off, we've now just been able to authorize the use of the hoods that have been designed as well. And to me, they look like an improvement on what was currently available in the first place. So I think this is mutual respect. This is being able to have conversations, knowing you can trust the people on the other end of the phone, and knowing that they're doing it for a benevolent endeavor to help people who are in their direst time of need. So I feel very humbled and privileged to have played a small part in this process. And I'm very grateful as well for being invited to share my thoughts today as well. So thank you, David.
Yeah, thank you very much. I'm delighted we got the audio working. I'm going to hand back to Helen, but before I do, can I just take this opportunity to thank all the speakers, not just for their presentations, but also for what has been a most remarkable experience for all of us who took part. It is something I will never forget for the rest of my life. Helen, back to you.
Wow. Well, I honestly don't know where to start. What an amazing adventure that you guys have been on over the last few months. And I know, having myself been involved with Nightingale, just what an effort you have put into producing these CPAP devices. We are very close to finishing today, and obviously a lot of you have had a lot to say. So probably what we will do with some of these questions is send them to you so that you can answer them for our listeners today, and we'll post that with the resulting show, webinar itself. So there's just a couple of questions actually. One of them just with regard to accelerated life testing on the re-engineered CPAP to ensure functionality and quality of products. Was that undertaken as part of the process? I'm not sure whether that's a question for Neil actually, or one of the members of the team.
I'd go for Mervyn and Dave, if I were you.
Okay, Mervyn, would you like to maybe tackle that question?
Actually, I'm going to deflect that back to the engineers. I presume that means just so that to show that the device doesn't wear out. So I think that's more of an engineering requirement. If I can pass the ball to one of my engineering colleagues,
I can pick that up, Mervyn.
Yeah. Thank you. Andy.
The devices are a remarkably simple device. With no moving parts inside. The valves, we did lots and lots of testing of opening the valve, closing the valve, and then the PEEP flow flag that we developed to help set the minimum oxygen level. We adapted the rig that I mentioned before, the pass-off rig, so that we had 2 CPAP flow devices, one simulating the breath in and one simulating the breath out, and that set up with a mannequin and a mask was sort of doing accelerated breathing tests so that we could we had the device breathing, and that helped with a lot of the development work that we did, and also gave some accelerated testing on that flow device. I hope that answers it.
Thanks for that, Andy. Yeah, that's great. This might actually be another question for the engineers as well, but one of our listeners has asked the question why you or maybe we missed this in the conversation, but why the original patent and design for the CPAP wasn't easily available? Why did you have to re-engineer and go back to cutting pieces up to do measurements in order to be able to understand the design?
Shall I go for that one?
Yeah, you go, Tim.
Yeah, so our brief from Mervyn and Dave was to keep it simple. So when we had our first meeting, was really, we likened it to, these days it's very difficult for anyone to be able to sort of fix their own car. So we were going back to the days of carburettors. So in medical terms, that means sort of moving away from all the touch screens and all the electronics and all the bells and whistles and going for something very simple. We actually tried to make contact with Philips, who they owned the rights for the Whisperflow, and I think we were. It's probably perhaps a generational thing that we were very close to finding the people within Philips who would have known the design details for this device, but we didn't quite join the dots. So since we've released the open source designs, we have been contacted by people within Philips who said, oh, if only we'd known, we could have helped out at that stage. So it was totally through the guidance of Mervyn and Dave that we went the route we did. We saw them as being the customers, and I think that's partly why our group worked, because we had this sort of golden triangle of the clinical need, the design, and the manufacturing all together.
Thanks for that, Tim. That's a really great answer, and it's good to know that Philips were keen to provide you with those details afterwards as well, which goes to show just how keen everybody was to work together. I suppose, and we're very close to time now, but one of the questions I'd like to pose to you is what do you think the future holds for this sort of collaboration? We've seen a number of companies and academics come together to solve medtech problems over the last few months. And it just goes to show how quickly companies can pivot to dealing with other problems. Do you think that this is something that we will see a lot more of in the future? And do you think that companies like Mercedes will be in a position to think about being prepared for these sorts of things in the future?
Sure, shall I go for that one? So, yeah, I think it's really shown what can be achieved. That we have got the skills. Again, I think we were unique probably globally that we could do this so quickly because we have got that high precision manufacturing base within the UK around Formula One. And certainly the group that's formed now is going to keep going in the future. So we've not stopped. We're looking at other products and other initiatives to support COVID, and that's certainly going to continue. I'll be my role is going to sort of carry on as a result of what we've done over the last few months. Because certainly before this started, I wasn't involved in healthcare in any shape or form. So I think it's had a big impact on all of us. I think it'd be nice for Andy just to say a few words because he's got some nice sort of feedback that he's had. So I'll just hand over to Andy.
Thanks, Tim. I think in the middle of March it was all hands to the pumps and working together as hard and as fast as possible. As Tim says, it's shown that the capabilities of motorsport manufacturing and engineering can help out. And as Neil mentioned, the automotive sensor proved to be a very capable mechanism. I think there is the opportunity for motorsport organisations to help further in the future. I think there's some strong engineering, analysis, manufacturing, testing, prove out logic within the motorsport world. So I'm confident that going forward, as you know, Formula One's going to shrink a little bit with cost caps coming in, that there'll be a gaggle of engineers that can be can change their careers a little bit, perhaps inside the Formula One teams, and can apply the technology that's been developed in Formula One to the medical world. And I think that'd be a great thing to do. It was one thing to help a driver win a race on Sunday, but it's way more rewarding to help somebody recover from a nasty illness.
Andy, I think that is an absolutely perfect statement to end this webinar on. I think it just goes to show just how versatile the engineering profession is. We have had a lot of other questions, which we're obviously not going to be able to answer today. However, we will make sure that they're circulated to all of the speakers and to ensure that they get a response to some of those questions that you've all been posing. So thank you very much for taking part in listening today. Thank you once again to this incredible group of people who have proved that engineers are not just tied to one profession, but can move across the industries and help solve problems and keep people alive. So thank you very much for listening today. Thank you for taking part, and we'll see you again very soon. Bye-bye.